All right, so remember that the definite integral represents the net area under the curve. In this class, we are assuming that these functions are always greater than or equal to 0. And so if you make that assumption, then this definite integral represents the area under the curve. Now, this is totally a for your information. You're not going to see something like this on the test where it says use geometry. There is a method, and I just want you to be aware of it, that you can technically use geometry to graph the integrand. So what you would do is you would say, okay, my integrand is 12. So if I graph y equals 12, that is just a horizontal line through 12. Then I have these bounds from 0 to 3. So basically I'm trying, when I find the definite integral, I am trying to find this area under the curve from 0 to 3. And if you look at this particular problem, this is just a rectangle where the length of the rectangle is 3, the width is 12. And so you could, one way you could do this to find this definite integral is you could just say, okay, it's a rectangle with a length of 3, height or width of 12, and so that gives us 36. Now, the reason why I said the geometry part is not going to be required is because technically we now have that fundamental theorem of calculus. And remember, the fundamental theorem of calculus says we use our rules. So the 12 would become a 12x. And then we plug in the upper bound minus the lower bound. And you'll notice that when you plug in upper minus lower bound, you get the same answer. You get the 36. So it doesn't matter to me if my student works through it graphing the integrand or fundamental theorem, you are going to get the same answer. Now, I do want to be very clear. You could potentially have a question on your test where you have to find the integral from 0 to 312 dx. The part that's not going to be emphasized is you must graph the integrand, that part of it. But again, this definite integral represents the area from x is equal to 0 to x is equal to 3. Two ways of finding that: graphing the integrand if possible, and then the way that usually works more often than not is the fundamental theorem.